we'll get started here. And as you can see, I've had a lot of problems getting Kubernetes to behave on this network. So we'll see what comes to life here in the next few moments. I've spent the last 2 hours trying to get it to start on this network. So that is one challenge you'll have whenever you want to engage with a Kubernetes cluster. If you want to run a private cloud on your laptop, and the network is a bit fickle, and often it is at a conference, conference setting like this. I'm not sure what the difference is. It has something to do with DNS. Certainly has to do with latency. And then things just don't quite work. So we'll see if my Kubernetes cluster comes up. Now, we're going to spend about 60 minutes together. We're going to talk about all kinds of fun stuff. I had some cool demonstrations that may or may not work at this point. I may have to get them working for the afternoon session. We'll see. May have to save them. But let's get started here. This presentation is around comparing Kubernetes to an application server. And so what I'd like to know from this audience here, how many people here have a Java background? Java. All right, fantastic. You're my people. OK, you're my people. Now, I've been doing Java since like 1997. And how many people here have been doing Java longer than 15 years at this point? Yeah, a fair number of us, right? But how many longer than 20 years? Yeah, right, Java's been out there a long time at this point. And so I want you to keep that perspective. Java's been there a long time, and application servers have been there a long time. And it might be that you've kind of written off this whole architecture at this point in time in your life. How many people here are Node.js people? All right, we got our Node people here. I like Node.js also. And it might be you're a Go person now, a Python person, Node, right? You moved on to Swift. You moved on to something, right? You gave up on Java if you could. And so I appreciate that. And my two presentations today, the one we're going to talk about now, it talks about the future of an application server style architecture, not an application server per se, but application server style architecture. And then a later presentation, we're going to show you how we've reinvented essentially the Java runtime to work from a competitive standpoint so that it actually can compete in this new world of cloud-native architecture, microservices, serverless, and those kinds of new advanced technologies. So that'll be what we show you later today. I do have a book that was, just so you guys know, this was just put up on the website in the last couple days. It is related to Istio. I'll show you Istio if I can get my Kubernetes cluster running properly. That's what I was trying to install there when we got started. But if you're interested in Istio, we'll talk about it in this session a little bit, and I want to show you parts of it because it does have a huge impact on how you architect modern applications. So Kubernetes and application server. I dare to put these things in the same title. So let's talk about that for a second. An application server, if you go look at Wikipedia, was defined as basically something that has an API, right? It has a set of APIs that we use. It has clustering and failover and load balancing capabilities. And it has this concept of developers to be productive, right? In other words, developers use all those infrastructure components and those APIs, and they go build their app, and therefore their app is portable across multiple providers in this case, right? So that was always a big win with application servers. You can move from WebLogic to WebSphere or to JBoss, which is the world I come from, or back and forth, right? That was kind of the big win. And so that was the purpose of these things. And so that is kind of my point here with Kubernetes. Kubernetes is the new backplane, the new infrastructure that you can put your applications on. And the cool thing about it is they don't have to be Java anymore. Now all the Node people and Go people and Python people and C++ people and all the people who are otherwise left out of all these cool things now have them. Okay, and that's what we'll see here in this presentation. Okay, so APIs, clustering, and developers. So that's where we're at. So I want to take you back to 1999. I mentioned, I asked for people who've been around doing this 20 plus years. This is for everybody. Even if you haven't been doing Java for 20 plus years, think about 1999. Okay, 1999, this is my favorite movie in 1999. This opening scene with Trinity, right, from The Matrix was amazing, right? Blew my mind in 1999. These were our top songs in 1999. You might remember these. Cher. I think she was only 85 at the time she did that song. But, she's still rocking it, right? That's awesome. Okay, and the US wins the FIFA World Cup. You guys remember that? I did this in Europe. Everybody was stunned. They're like, what are you talking about? And I was like, for real, people, and I want you to check your bias for 1 second. We did win the World Cup, okay? And the amazing part was all those Europeans were like, oh, yeah. And even as Americans, you're like, oh, yeah, we did win the World Cup. So I want you to think about that for a second, because 1999 was certainly the year of the ladies, for sure, okay? In sports and entertainment as well. But it was a different era back in 1999, all right? And so we had these things called application servers. And I want you to think about the Java developer from back then. We had articles like this one from InfoWorld where it talks about the Java tug of war. It's pretty interesting. What's happening in the Java market? And I love this one. Java takes the lead for developers using Java or XML. I'm not sure what that comparison was, but okay. Java overcame XML as a programming language. Very fun stuff. Talks about Java tooling, and I love this one right here. It was only $25,000 for 10 developers to get started with an IDE. Think about that. We paid $25,000, $2,500 per developer to have an IDE back in 1999. Things were very different back then. We spent tens of thousands of dollars to do Hello World. As a matter of fact, I added all that up. It was $500,000 to do Hello World back in 1999. Hello World, right, with a database and an app server and appropriate hardware, et cetera. And so we can see BA WebLogic was by far and away the winner in 1999, right? The product of the year for InfoWorld there. And this is the part where I talk about the $500,000, right? This is really what it cost. I actually called up friends from Sun, well, what was Sun, right? And said, can you go find the old price books for those old Solaris boxes we used to purchase? So we used to have Solaris boxes. We used to have HPUX boxes, AIX boxes. We had all these old school, and they were big too, like this size machines, right? And eventually we got to the pizza boxes that fit in 1U rack-mounted servers, but we actually had things that were more like mini towers back then, mostly back in 1999, and that's how we built our applications. And it cost a lot of money. Hello World was this kind of money to get started. And then you had to pay about $80,000 per year to maintain it. So the world was very expensive, and also this meant it was very limited when it came to developers who wanted to build net new web applications. This was not for the average person to go say, I want to start a web app today. I want to have a startup today. They had to go get VC funding to have a startup back then, because that's what it cost. Okay, so the world has changed dramatically since that point. Does everyone feel that way too? It's now more open to everybody who has an idea, who can go try something and see if they can make magic happen. I think that's important. Okay, so let's talk about APIs. And I want you to think about your application. If you are an architecture person and you built an application before, you probably started on the whiteboard and you basically said, I have an application that has some client-side user interface, be it mobile or web or whatever it might be, probably web at this point in time, and I'm going to connect to some data source back there at the bottom, and I'm going to have these nice 3 clean layers of user interface, of logic, and data access. This is how we used to think. And we used to build applications like this, and we would nicely compartmentalize it. We want to modularize it, and it was kind of cool, right? With our UI, we'd talk to our logic, we'd talk to our data access, we'd talk to our database, and that's 80% of what we do as software developers, especially in the modern enterprise, is we get data from some user of some sort, even if it's just an API and business-to-business transaction, and we route it through some logic, shove it in a database, and we get the data out of the database and present it back out through an API or web source, right, or web page. That's what we do. And it might be a mobile thing, it might be a web thing, it might be an API, it doesn't matter. It all works basically the same way. And so, but it looks like this now, okay? Because over time, we had a lot of cooks in the kitchen. And this is where when we come to that code base later in life, we go, God, those people really sucked. But you don't actually know the constraints they had to work under. I worked on projects where we needed 6 months to build the thing, and we had 6 weeks. In which case, every shortcut was taken, right? Every sloppy process that you could throw in there to make it work, every Band-Aid you could think of, you would use. Because you had to, based on constraints that were placed upon you by some other person who didn't have, let's say, appropriate expectations. And so things get ugly over time, all right? And the good news is, if you think about all these cooks in the kitchen, there might have been 30 or 40 or 50 hands on that code base over time, right? It could have been 50 people that were involved with it, and so it could have changed dramatically. One thing that's kind of cool about it, though, is if you think about your stack, these things still hold true, right? There's some form of web tier, what might have jQuery, it might have, Ionic or Angular or Vue these days, right? Vue's the cool kid on the block, React. And of course, you have some form of middle tier there. Some people still using struts to this day, but Spring MVC is also very popular. There's JSF, there's Wicket, right? There's all kinds of things. You can kind of see there's Spring Beans and EJB, CDI, all these things in the middle as well. But this is often the stack we're dealing with. And a lot of people still using stored procedures out there, right? Some of you might be using things on an AS400 with RPC and things like that. There's all kinds of cool stuff still out there in our legacy systems. But we have a stack, okay? And I want you to think about the APIs that existed in the Java EE app server ecosystem, because we're still using many, many of these things. We might not use them all. We might pick and choose our favorites. But certainly people have used things like JDBC, Java Database Connectivity. People have used things like JAX-RS for a RESTful interface, JAX-WS for web services, right? SOAP and WSDL and all that good stuff. JPA for talking to a database, transactions. All these things were commonplace and still are in modern infrastructure. But the good news is we can pick and choose the ones we want now. If we don't want JMS for this application stack, we don't have to have it in our infrastructure any longer. There is no JMS. We can pick and choose how we get that, okay? So there's a new set of specifications, right? Java EE has moved over to this thing called Jakarta EE under the Eclipse Foundation. And they're working on the next generation of APIs to describe what those things are. And then you can also think of this thing called MicroProfile, which is another group, a different group at Eclipse, that's moving incredibly fast and basically saying, how do we modernize all the APIs that matter in this cloud-native world that we now live in? Some of these APIs don't matter anymore, right? They were very important back in the day. They're not so important any longer. So how do we actually pick and choose APIs that matter going forward? So that's the MicroProfile work that you see out there. You can see there's a ton of different fat jar architectures in the Java ecosystem that people now use. Drop Wizard was the first to come out with this concept by using Java EE APIs and basically saying, we can bundle it all into a fat jar and make that available. Vert.x came out about the same time frame. So instead of using Java EE APIs, it had a whole new reactive API for a reactive application stack. So those two folks came out a long time ago and were the first to basically say, you don't need an app server. You can bundle everything into a single executable. Spring Boot, of course, adopted the same principles and is, of course, very popular at this point in time and is by far and away the most popular solution in the market. Okay? But you can also see Thorntail, which is what we had for MicroProfile implementation. You also see Micronaut here, which is the new kid on the block who's basically showing you how to compile Spring Boot-style applications into a native executable. But more importantly, it's actually dealt with things called ahead-of-time compilation, so it actually loads faster, starts faster, things like that. In other words, it's making different decisions about how application logic should be started. So a lot of interesting runtimes are happening in this space, a lot of innovation in this space, well beyond what we see with traditional app servers. So that's the good news for people moving into this new modern world of application delivery, is that you can now start taking advantage of Drop Wizard if that's what you need, or Vert.x if that's what you need, or Spring Boot if that's what you need, or Micronaut if that's what you need. And there's a new thing that I'll show you this afternoon called Quarkus. All right, that's something we just gave birth to just a few weeks ago at Red Hat, and it's basically the concept is very similar to what you see in some of these other ecosystems. You can compile it down to a fat jar, but you can also compile it to a truly native executable, into a single file that you can then throw out there on a Linux machine and then run it as you would a C++ application or Go application. All right, and therefore you still use the Java programming language, you still use your favorite APIs that you're used to, like JAX-RS and JPA, but now you have a natively executing application. So there's just a ton of innovation in this space, okay? So just keep that in mind. There's also the Java ecosystem APIs. So forget about the Java EE stuff. Let's say you don't care about JPA or JDBC or JTS or one of those things, and oddly, we mostly use all these things, right? JAX-RS, Servlet, right? JSP, we use these things. But there's also the ecosystem of APIs, and this is really what sets Java apart from all the other ecosystems. Okay? This is why Java continues to be the king of enterprise solutions, because if you have a problem, there's probably a solution for it already. Now, what I really love is for people who, when you go out and talk to people who work at large organizations, they have their own special custom MVC framework they created, right? Or better yet, they built their own message broker, or their own database engine, or their own whatever, Forget about the fact there's 25 MVC solutions in open source, or 25 database solutions in open source. I need to build my own, because our needs are special. That's a very common thing to do in the Java ecosystem, and the cool thing is, you can do that. If you're a Node.js person, you do the same thing on the Node.js side, right? You build your own MVC framework there too. It's just because we can. We're software engineers. We want to be creative. We want to do our own thing. The good news is, a lot of these problems are solved. All right? And so you can look at some examples here, whether it be Apache Spark is a great example, or Spring, or Hibernate, or Hadoop, or look, there's just a million examples that you already use. Camel, right, when it comes to enterprise integration patterns, Kafka if you want, a distributed log and that form of messaging, Akka if you want some form of reactive solution, Vert.x is another reactive solution, so you have a ton of things here, okay? So APIs are now universally available to you in many, many, many forms. And the good news is, as a modern application developer in Java, you use Drools when you need a rule engine, right? You use Camel when you need distributed integration enterprise integration patterns. In other words, you know how to use these things already. So let's talk about clusters for a second. Let's talk about clusters, okay? And actually, let me show you a demonstration if this one will work for me. This one is not set up on this local machine. Let's see here. Looks like those guys started. All right, let me try something over here real fast. This is not the demonstration we're going to get to just yet. I am trying to see if it'll build these 3 microservices for me. All right, we'll come back to that. What is the window I want to look at here? I'm trying to remember all my windows. Since I was scrambling to get things set up. I'll show you that one later. This one. Okay. Let's look at this one. Okay, and actually this one, you guys can, we'll see if this works for me. You guys can help me out with this one. This is the Popular Movie Store. That is this guy right here. Not that one. Those are some notes I need for later. This one. Okay. So you can go, let's try this. Go to bit.ly. Let me double check this is the right URL. Because I change these things all the time, so it might be that it's changed. And my network is very slow. Yeah, there we go. So you guys can go to this bit.ly URL here. Bit.ly pop movie 3. Let me bring up another window over here. And let's see it. Okay, I want to try something real fast. This could fail spectacularly, but the idea is that it's a simple shopping cart application. It's a Spring Boot application that we've done something very special to. So it's a normal, everyday Spring MVC, Spring Boot application. And I can put things in my shopping cart over here. Dun, 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 dun. And you guys can do the same. And so what I have is a standard shopping cart now. And you notice it says Movie Cart Burr. Now let's see if we can try this real fast. Let's see here. This one. Okay. And what I'm doing, by the way, is I have Amazon running over here. I have a OpenShift, which is our version of Kubernetes right at Red Hat. So I have OpenShift running over here on Amazon. The good news is, you know, OpenShift looks the same everywhere you go, even though Amazon looks very different from, let's say, Google. Right? Looks very different from Google, but I have OpenShift running here. And then I have Azure, which looks very different than Google and Amazon, and I have OpenShift running here. And this is the demo that's not quite working for me quite right, but I think this part of it will work. Let me go into the movie application. Let me see how I last left it, because I hadn't had a chance to look at it in a while. Okay, and here's what's happening. You guys are now talking to one of these 2 servers you see here. So if you actually have connected, and did anyone put anything in their shopping cart? Okay, fantastic. So you're basically connected to one of these 2 things called pods, right? So Kubernetes has basically the concept of an application container, or basically the Linux container, and it's actually multiple Linux containers is known as a pod. So think of the pod as the computer in which you're running. Okay, so for a Java person, Node person, Python person, that's the computer I'm running on. You can actually see at the bottom, you can actually see the bottom of the screen here, the name of the server you're on. Okay, so that's kind of tiny, right there. So you can see that's the server you're running on. I'm curious to see what my other one says. Right here. Okay, you notice there are 2 different server names. So that's the computer, that Java application, that Spring Boot application thinks it's running on. And that's one of these 2 pods you see right here. What we're going to do now, though, is go back here. I'm going to roll out a different version of this. I forget what I last said of that. But basically, I'm going to start up a different pod right now. You can see that pod is basically in a not ready state. It's going to go into a ready state and uses this concept of a liveness probe and readiness probe. So this is one thing that's interesting and different about a Kubernetes cluster versus what you might have interacted with before. Not only does Kubernetes ensure that your process stays started all around the cluster, all around the different nodes in that cluster, it also does these 2 checks all the time. Are you alive? Are you alive? Are you alive? And are you ready? Are you ready? Are you ready? And it's constantly doing those 2 things. Are you alive? And are you ready? And because of those 2 checks, you can have some fun with it. Okay, so I'm bringing it up. And basically the first check is, are you alive? If you're not alive, you're a walking zombie. It shoots you in the head and starts you someplace else, right? And if you're not ready, you're not part of the load balancer. That's the distinction. So alive, you got to be alive to be ready. But the first thing is, are you just a walking zombie, some process we can't talk to anymore, in which case we kill you for good and start you someplace else. And ready means, are you ready to accept load from your users? So I have I'm bringing up the second pod. I'm going to crash these previous two. All right, so I'm tearing those down. The second one here is coming online. And let's see if this works for me. OK. And there we go. Notice the word Burr is gone now. So basically, a whole other version of the code base is now in production. And you might not, it might be kind of subtle. Let's check this one over here. Right? See, over here it said Burr before, because that was the version I had out there. Let me hit refresh here, and Burr is gone. But all my state is preserved. Okay? Everything in my shopping cart is still there, but a whole new code is now in production. And so that's kind of the cool part about this particular demonstration that we call it Pop Movie Store. Again, it's a standard Spring Boot application. Let me see if I can find it here on my hard drive. Dun, dun, dun. Why is that? Failed to down. Cancel. I have to go back and look at that. No, not here. Different set of windows. I'll show you what the code looks like just briefly. Dun, 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 dun. There it is. I'll bring it up in Visual Studio Code. Okay, and actually, here's the deployment YAML that is interesting. So again, the Liveness probe and Readiness probe basically say call this, delay about 35 seconds. And the reason this is important, if you notice, there's this health path right here. That's actually in the code itself. So if I come over here and go look at the Java code for that, and let me see if I can remember which one it is. Is it this one? No, dun, 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 dun. Not that one. That one right there. No, home controller, that's where it is. Right there. This is the logic that's interesting. Basically, it's saying, I am not healthy, I am not ready until I know I have collected all the data from all the other nodes, all the other pods in this case, they're about to go away. So this is actually a very cool idea. So basically, Kubernetes won't do the rolling update of your new thing until the old thing and the new thing, in this case, have communicated and say, do I have all your shopping carts? Yes, good. Shut down the old ones, start up the new ones. So this is a very powerful concept, right? This is a fairly advanced use case, right? A lot of people don't use it this way, but this is what it's for. So you can warm up your caches. You got to get the JVM started. You got to get your framework started, right? Spring, let's say, on top of that, whatever it might be. You got to get your database connected, your caches warmed up, whatever else you have to do, authentication, authorization, set up TLS, whatever you got to do, and then you are ready. So this concept is actually very powerful. But this concept of how to start and stop things all throughout a Kubernetes ecosystem, like you saw me do here, right? Let me go ahead and I can crank these other guys back up. It's as simple as that. The cool thing about Kubernetes is you declare how many of these things you want. In this case, I just said I want 2. And it goes and finds a place to run those 2 components. Okay, and it runs those 2 components based on the parameters I set here in the deployment YAML. Basically, I need this image. Where's my image name? Dun, 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 the image name. It might not be in this one, because this is actually a fragment. Yeah. So I'll show you a proper deployment YAML in a second, but this is actually a fragment. You can actually take these YAML fragments. But the concept is very simple. You basically decide what the parameters are to deploy that component within the cluster. You can kind of see here's the ports that we want open, the Liveness probe, Readiness probe. Here, I'll show you a better example. Dun, 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 dun. Let's see here. Yeah, let's look at, maybe a more fun example is this one that I'll show a little bit later today. Yeah, let's look at these. These are a little bit more fun. Like here is my another Spring Boot one. Here's the image that I want to deploy, the actual Docker image I want to deploy, the port that needs to be open, how much memory that I need to run that, how much CPU that I need to run that. So those are constraints that you apply at the cluster level and again your Liveness probe and Readiness probe. So just by specifying these basic settings, I'll make that a little bit bigger, okay, you now can determine how that thing executes throughout the cluster. So you don't have to have an app server which used to do these things. The app server used to do I'll run your app. I will ensure it stays up. I'll load balance across your application. Now, Kubernetes is doing those same things for you. Okay? And actually, let's go back over here. Let's see if this works for me. Let's kill this one. All right. Kill that one. Come back over here. Let's see. All right, come on. Connect. And let me go over here and check this one. Man, my network is slow. But now it says movie cart Burr. So did anyone else try it? Did you guys get back and forth, right? So you see all your data is preserved. So this concept is very powerful. but it's a very powerful construct you have within this Kubernetes ecosystem. So let's talk more about clusters and come back to this demo. Okay? Right, so let's talk about this. Okay, so the cluster from this perspective means that we're going to take a whole bunch of different computers, pretty much at this point inexpensive 1U rack-mounted servers that are Linux-based, that live inside a rack, right, inside your data center or inside your public cloud provider's rack or whomever provides your servers, okay, at this point. And they're going to basically put these servers together, and you're going to treat them as if they're one big computer. All right, that's really the point of the cluster. And you can basically start and stop across that cluster. You can add and remove nodes as needed. You can basically do a farm deployment is what we used to call it in JBoss world, which meant that if I deploy this component to one node in the cluster, it dynamically finds its way to all nodes in the cluster. We used to call that a farm deployment back in the old school WebLogic, WebSphere, JBoss days, right? We would have our configuration there, our load balancing, our failover, our service discovery, our logging, our distributed logging is all handled for you at this level. And you now can leverage multiple computers as if they're one. That's really the point of this architecture. And this allows you to scale better, but more importantly, allows you to have a level of dynamic behavior across your workloads so you can move things back and forth as needed. It might be that you have a certain application that is spiky at Monday morning at 9 o'clock in the morning, and you might have another workload that's spiky at midnight because it's all when the Asians come online and they're using the software. Right? It's basically when you might actually have different user bases that have different loads on your system. So you can think about running your ears or wars across this infrastructure if you're a Java person. But the thing that's kind of interesting is this concept of the domain controller that we had with WebLogic and JBoss, et cetera. Right? We had this concept that there was a certain node that we talked to that had a certain set of APIs that talked to the cluster on our behalf. You might remember the domain controller from WebLogic. Anybody have one of those? Anybody still have one of those? No one uses WebLogic anymore? Wow, okay. Things have really changed in this world. They were the winner in 1999, didn't you see that? Okay, but now I can have this concept where it's a Kubernetes cluster. Again, the same process applies. I have this master node which has the API that I interact with. It also has etcd, which is its internal database for representing the data that you want, meaning I want this deployment of this application, this deployment of that application with this configuration. That goes in etcd at this master level. And then, of course, the scheduler determines which of these nodes have the availability to run the application that you have. Okay? I want to deploy to that cluster in some form or fashion, whether it be my Spring Boot application, my WebSphere, my WebLogic, my JBoss, my Node.js, my Python, my Swift, whatever it might be. It doesn't really matter at this point. And the cool thing is, it doesn't matter what language you program in or what runtime you love, it applies to all of the above. Okay? It applies to all of the above. Now, this is a short history of microservices. I like talking about this because people have been thinking about microservices now really aggressively in the last couple of years. But we've been talking about microservices for quite some time. I mentioned Dropwizard and Vert.x a while back, right? They started in 2011, but you also see Netflix being born in open source in 2012. That's where they showed us how to do things like circuit breakers, service discovery, server-side, client-side server load balancing, right? Service load balancing, that's Ribbon, Hystrix, and Eureka. We learned about microservices as a definition in 2012, right? Docker was born in 2013, Spring Boot born in 2013, Kubernetes born in 2014, and that latter point there created the perfect storm for us to get excited about microservices. To this day, you probably have a boss in your organization who's like, we got to have some microservices, right? Surely you have heard that from some manager or another. We have to have microservices. That's going to make everything better. And then do some DevOps while you're at it. That's kind of how it works, right? And so the cloud was born back here. You can kind of see Dropwizard, Vert.x. There's Netflix, the Netflix stuff, and of course the perfect storm, as I called it. So we've been thinking about this problem for quite some time. Okay? And as a matter of fact, we came out with Kubernetes in 2015, so we call it OpenShift, right? That's our distribution of Kubernetes. And to prove the point that this architecture was so fundamentally different from the rest that came before it, in this demonstration, you can go look at the YouTube video, we launched 1,000 containers live on stage in 2.5 minutes. We had a fairly big cluster. But 1,000 containers live on stage, and we invited the audience to claim one of those containers. Each one was a little Node.js application server where they actually uploaded something from their phone, planted a flag basically in each one of those containers. And so we did it in 2.5 minutes. So it was a game-changing way of thinking about it because Kubernetes comes from Google's way of doing things at scale, right? That's its heritage. It's the Google way of doing things. And so we jumped on board that project very early on. So you can also see that a huge portion of the ecosystem has also fallen in love with Kubernetes. People who were previously at war with Kubernetes, right, now said, yeah, we like Kubernetes also. And that includes Amazon, by the way, at the bottom there. So everybody's kind of capitulated now and said, yep, we like Kubernetes also. This is the CNCF. You can see what's happening inside the ecosystem. And this is an older version of this screenshot. So you actually can't get a screenshot of this anymore. The number of projects and partners within the CNCF, Cloud Native Computing Foundation for Kubernetes, is insane. This is the fastest moving ecosystem we've ever seen in open source history in my mind. I've never seen anything like it before, and I've been doing this for 30 years. So it has fundamentally changed the way we think about computing platforms going forward. I'm not saying it's the be-all, end-all, meaning it's not going to be the winner, let's say, 15 years from now or 100 years from now. We don't know what that world looks like. But it's certainly the winner today and will be for the next several years. So the Kubernetes cluster, as I mentioned earlier, has this kind of architecture, the master and these nodes that you're interacting with. I do like making the point of DevOps, because if you notice here, see Dev and Ops, we can now collaboratively use this common platform. The operations team ensures the infrastructure is always up. The developers deploy their apps on top of it. That is another thing that Kubernetes has changed for most organizations, is now dev and ops can come together and use a common platform. So they're not living in this world any longer, hopefully, with the wall of confusion in between, where you think you can throw it over the wall and hit the other person in the head. Okay? Hopefully we've eliminated that from our way of thinking. We can work together to deliver better software faster. As a matter of fact, with this new architecture, you don't need the Netflix stuff anymore. Right? You can actually build microservices with Node, with Python, with Go, with anything. It doesn't have to be Java any longer. So that's another reason why I've said Kubernetes is your next application server, and it's for everybody, not just Java programmers. Okay? So you can think of this as the key capabilities that we need for a microservices platform. How do we define our APIs? How do we govern our APIs? How do we handle service discovery, invocation, scaling and elasticity, resiliency of those invocations? How do we deal with a pipeline that makes the thing move from A to B throughout the workflow to get it out the other end? Logging, authentication, authorization, monitoring. All these things now can be addressed in one of these platforms. And you just have to choose which Kubernetes vendor or distribution you wish to work with, because there's a lot of them at this point. Amazon has one, Google has one, Microsoft has one, Pivotal has one, Rancher has one, Red Hat has one, everybody has one. Okay, Mesosphere has one. Everybody has a Kubernetes distribution at this point. Now this is the demo that's not working for me, because I broke the system. But I'll show it to you anyway, just partly working, just because it's worth doing. Maybe I'll get it running during the break. But here's what it looks like. Let me find the right window here. Dun, dun, dun. If you think of that Amazon instance that I have and that Google instance that I have, let me go to the right place. Do here. I basically have an application that's distributed across the three clouds. The problem is the one that's on-prem is not working very well. But the way the application works, and you can kind of see it right here, okay, and just put a message in. It basically, and you can even go to this URL if you want, but the problem is only one cloud is working, so it's the bit.ly hybrid cloud demo there, okay? Hybrid Cloud 3. It basically will take your transaction through the user interface, route it to the local node, in this case Amazon, and then of course it would become the on-prem, and then from on-prem to Google and over to Azure. But the on-prem one is dead. But this is another way of thinking about application infrastructure. So this uses something called AMQP, if you guys have heard of that protocol before, and something called the Apache Cupid dispatch router that allows you to basically spray transactions, route transactions anywhere around the globe. All right? As a matter of fact, my Google's running in India, my Amazon's running in California, and my Azure's also running in California, but that doesn't matter, right? You can have them anywhere, but my local server has misbehaved. I know we're running a little bit out of time, but let me go ahead and show you a couple other things while I'm here. So let's see. I actually started a different Kubernetes cluster. I started Istio on it. I need to see if my pods came up. Get pods -in tutorial. Nope. kubectl Kubernetes tutorial. Let's try this. Get deployments. It looks like nothing deployed for me here. Let's go look at this real fast. And not you. Not you either. Need to make this a little bit smaller so I can read it. Why did those not deploy? I see that I have some errors there. Where is, okay, here we are. So this is actually a very simple application, but I've been having problems getting it deployed. Oh, I see what the problem is. I see what the problem is. I think I see what the problem is at least. All right, let's go try it real quick. I just want to kind of show you what it, at the bare minimum, what it takes to deploy a simple application. Let's go to customer, Java. I have multiple examples of this: Quarkus, Spring Boot, Camel, MicroProfile, things like that. Let's just look at the Spring Boot one, make it simple. Okay, let me bring this up. Very simple application. This is a simple Spring MVC style application. And basically what it is, customer calls preference, and preference calls recommendation. So it's 3 little microservices in a row, very simplistic. You notice there's no actual extra code in here. It's using standard invocations, if you will. It's REST template for calling something else. It's doing try-catch blocks for dealing with exceptions that might happen through the network. Nothing too fancy there. Let's see here, Docker images, grep. Let me see what Docker images were created. I basically created this cluster right when we were walking on stage here. So that can't connect to the Docker. That's probably because of minikube-p. This should be the Istio one, Docker env. Let's see here. All right, so now Docker images. Okay, now Docker images. Grep example. Maybe it's example. Okay, so looks like none of those did get built. All right, let's Docker images. Make sure this is connected to the same Docker daemon. No. I want to do this over here. So you're actually seeing how the sausage is made a little bit. If you come to one of my 3-hour workshops, I walk people through this whole entire process. But otherwise, you normally don't want to show this for a generic breakout session. But let's see if I can figure this out real fast, just to get something deployed. So here's my Docker file. That looks fine. There needs the target customer.jar there. Let's do the ls target. There is customer.jar. So Docker build -t example customer and dot. See, let that build, and of course you can kind of see here I had not built it yet in this cluster. The cluster was just created, so therefore it has to do the Docker pull from Docker Hub, downloading everything across the internet, which is of course going to be very slow, and that might actually be a little bit too long for me to wait. We'll have to see how that plays out. But the thing that's very simple when it comes to Kubernetes, all you have to do is build your application, right? Maven build, npm, whatever it is you use to build the artifact that is to be deployed. Then you have to build your Docker element, your Docker image, right? That's it, right? Just do a standard Docker build. That's what's happening here. And then you need the 2 extra YAML files from Kubernetes. And that is the deployment YAML and service YAML. And so those are down here. And Kubernetes. Okay, so that's where they are. And so let me see if I have the Istio CTL. I'm not going to bother with the Istio right now. It says kube CTL apply -f deployment YAML. Get that deployed. And let's do this over here. Watch kube get pods. Oh, where did I put it? Get pods, all namespaces. Helps if you spell all namespaces correctly. Let's see here. Where did I put customer? Tutorial, right? Cube and let's see if it's here. Okay, and there's our customer application running. I can actually do kubectl exec. No. IT. Bin bash. I can actually SSH into it. Localhost 88. Localhost 8080. Come on now. DF. There it is. So there's my Java application. I should be able to hit it on localhost. And yet it's not responding. Why is that? Yeah, it is 8080, not 8000. I keep my node apps on 8000. Interesting. And let's try this other trick. kubectl applied -f and service. So that's the 2-step process to actually deploy a thing into Kubernetes. Yet it does not want to behave for me now. -p, IP, what is this? Istio IP. All right, so 192.168. This probably won't work since it didn't want a localhost on me, but we'll try it. And then the port number for that service was, where'd it go? kubectl, get services. 32, don't need that. Let's see if that'll work. Probably won't work because the service is not responding. So my Spring Boot app came up, but it's not responding on the port. I don't know why. All right, let's go ahead and try to finish up the slideware portion of this. I can show you more things, and I'll get the rest of this working here in a second. Okay, a couple other things to understand that are important to know. As I mentioned, you can have access to all the different frameworks and tools and open source technologies you want. The way we make that shopping cart failover thing work is actually using something called Infinispan. Infinispan is an in-memory data grid that's basically maintaining that shopping cart on behalf of the user, and therefore the application itself can be stateless, and the statefulness is held somewhere else. Okay, you could use a regular relational database for that too. A lot of people do that, but if you want to keep everything in memory and basically have those pods fail over to each other, that's what we were doing with that shopping cart example. And so that's using something called Infinispan here. There's also this technology called ActiveMQ Artemis, right? So this is AMQP message broker. How many people use ActiveMQ already? Okay, a fair number of you already use ActiveMQ. So you can use that technology as well. That's another project that we sponsor from Red Hat standpoint, and that might be something you would use. And of course, we show you how to deploy that in a Kubernetes architecture also. We actually have a new technology called InMass that takes this and makes it self-service. So a user, a developer simply says, I want a new topic or a queue, as opposed to managing a broker, as an example. And by default, the broker is just running on one of those pods in Kubernetes like any other process running in Kubernetes. So this is the InMass technology I was just mentioning. So think about that if you're interested in some form of self-service API, cloud-like architecture on top of Artemis, on top of ActiveMQ, on top of Kubernetes. Okay? And then the Cupid dispatch router is the one that I was talking about earlier that allows you to route transactions from place to place to place. Again, it's a fairly stateless architecture. It doesn't actually persist to disk. It's not a broker by any stretch of the imagination. It is a AMQP-based router. So it works with any AMQP 1.0 based system, but you can route transactions from broker 1 to broker 2 to client 1 to client 2, et cetera, et cetera, et cetera. And that's what we're doing with those transactions around the different clouds. StremZ is another thing we've also Kubernetesized. So in other words, if you're into Apache Kafka, you want to run it on Kubernetes. So you could actually use this set of templates, deployment YAMLs, if you will, and actually what's called an operator to basically deploy into your Kubernetes cluster with StremZ. By default out of the box, it sets you up with 3 zookeepers and 3 brokers. And then, of course, you have a full HA environment for that. If you want to set it up on a local machine, you can do it 1 zookeeper, 1 broker, as another example. Okay? This is also an interesting project you should be aware of called Debezium. This basically takes all the data flowing into one of your application stacks into one database, one of your normal application silos you have in an organization. It takes the transactions that are flowing into that database and routes them through Kafka to send them anywhere else on the globe you want to send them. So if you had, we all know about database replication at this point, but typically you have to do database replication from Oracle to Oracle or SQL Server to SQL Server, right? This could be MySQL to Postgres. Because what it's doing is simply stealing all those transactions, intercepting them all, create, read, update, delete, and then including some DDL commands, and sending them out through Kafka, and then you can do whatever you want to with them. It's a very neat project that we have also. This one for SSO, if you're interested in some form of SAML or JSON Web Token, right? I want some form of single sign-on solution, and I want to apply that to my Node applications, my Java, my Spring Boot, my Vert.x, my whatever applications that you have. Then you can use this sort of thing for that. Another great open source project. And Eclipse Che, I don't know if you guys have heard this project. It is a IDE in your browser so that you can run it in the Kubernetes cluster directly. So you don't have to have a local host IDE. You can have it as a pod in Kubernetes, and that's where your IDE runs. The cool thing about that is it means you don't have to check out code locally and figure out how to get your Maven right, which is always a big problem. I've run a lot of workshops, and a lot of people don't have a local working Maven. Right? It just doesn't work for them. In which case, having it in cluster means you're dealing with the actual infrastructure that's there, including Maven, all the right Docker-based images, all the right Linux that needs to be underneath there. That's all in cluster, which is pretty cool. So this is some information about that, and there's a link you could try here as well. And by the way, the link for this presentation is a bit.ly cube app server. That's a user interface of Che, and that is the end of the presentation. Let me see if there were some questions. How much longer are we going to? About 11:15? Is that what, you guys are supposed to put questions in this Slido thing, which I've not seen before. 11:15? Yeah, we need to be C, okay. Let's see what happens with this thing here. If I had to migrate a large monolithic application to Q, what would be your approach? Okay, actually that's a great question, and let me try this real quick. I have all these random presentations that I don't give because I'm always running. Let me see if I can kind of show you this one real fast. This is the 9 steps one that I do for O'Reilly. This is the intro to Kubernetes thing, but I don't show these part of the presentation. Here's real simple. The common strategy you see for monolithic applications moving to Kubernetes, one is just to move the monolith, okay? Just pick up your monolith and move it, because it still works. The nice thing about Kubernetes is statefulness still works, okay? But here's the actual solution that people like to talk about. So they use this concept called the Strangler Pattern that you hear. So I call it the hug now, because Strangler will sound so violent. So you want to hug your application. You have this big old monolithic application you've built over time. It has an ugly infrastructure inside it. But what you want to do is figure out how to surround it with these additional microservices you've built the modern way, whatever they might be. It might be a Java, it might be Node, it might be something else. But you can basically basically pull things out of the original infrastructure and pull it over to one of these other components. And then over time, right, you basically have removed the ugliness of that original monolith, and you can shrink it by refactoring it and pulling out those pieces. And then, of course, you can easily add other message queues or brokers, and then other integration solutions, reach out and touch other monolithic applications. So this concept does seem to be the most common pattern. Either you just move the monolith and leave it and be happy about it, and you can also see monolithic applications that deploy on OpenShift or Kubernetes every week. So they deploy as fast as once a week if you have everything else right. But if you want to deploy faster than once a week, you might use this approach to basically handle the microservices and move in that direction. Let's see, does that answer your question? Let's see, Istio providing additional Kubernetes for security, observability, and traffic management. So that is the 3 big ones. So basically, Istio on top of Kubernetes gives you the ability to not only do dynamic routing logic for really advanced smart canary deployment, but you also have MTLS as well as authentication, authorization, and RBAC. So you get encryption over the wire. That's one of the demonstrations often show is how to encrypt over the wire, as well as additional auth in, auth z. But you also have the observability factors, which I don't have those running right now. They're not running. They're kind of over here and dulled out. But you have the Grafana, you have the Jaeger, you have the Kiali. So you can see your service graph. You can get distributed tracing. You get all your monitoring. All that's part of the architecture there in Istio out of the box for observability. So very big wins from that perspective. When it comes to Vert.x, Spring Boot, or Quarkus, well, my current favorite is Quarkus. You'll see me demonstrate it later today, where we'll show you exactly how to build an application for, let's say, database CRUD operations with Quarkus and get a feel for how it works. The biggest win in Quarkus is that you can actually have this live reload feature. So if you're a Node person, okay, you write code, you hit save, you hit refresh. Code, save, refresh. Code, save, refresh. That's what Node people do. And Java people were like, what? That's crazy. We never had that before. Now you have it. Okay? So you have a feature the Node guys have had for a long time. The cost of a Java app inflation adjusted. What does that mean? And where'd it go? $1 million for Hello World? Oh, yeah.
Was that in inflation adjusted dollars?
No, that was in real dollars back then. Yeah, that was real dollars back then because I asked for the pricing of that time. So that was specifically to the $500,000 for Hello World. Yeah, now the good news is if you're a Python person, Node person, Java person, you pay nothing except for maybe a T1 micro at Amazon, right? And if you use some certain VPS solutions, they're $10 a month. So that has changed. What does Istio programming? Okay, we did that one. If you're running OpenShift on multiple clouds, are these OpenShift instances referencing the same domain? The answer to that is no. They are not referencing the same domain. Right now, all Kubernetes clusters are fully independent of each other, and you have to basically log into each one and manage them all individually. That is something we're working on in the Kubernetes community, this concept of Federation 2.0 or Federation V2. I don't have a demonstration of that working with me right now. It takes a little bit to set up, but there is something you should be aware of. And if you actually go to a website we just launched called Operator Hub.io, you will see, so these are operators. This is the new thing on top of Kubernetes, right? So these are intelligent controllers on top of Kubernetes. And you can kind of see, here's how we get Couchbase, etcd, CockroachDB, things like that. But there's one called Federation here. And if you lay that down on top of your different Kubernetes clusters, you can then manage them as one. It's kind of the idea. In other words, all clusters look like one cluster. When you do OC get pods or whatever, get namespaces, you can see across them. And it handles the fact that if you deploy an application in one, it replicates that application deployment in the others. It does mean you have to have a common Docker registry so that they can all pull from the same images. That's the critical thing to understand there. So whether it be Docker Hub or Quay.io or some other registry that you might use. So that's a very powerful concept. And it is certainly part of where we're going as an industry. So you're going to see a lot more of that one. We mentioned shopping cart persistence already. And where can you get the slide deck? This particular slide deck that we showed you was, where'd it go? If you look at the link down here, bit.ly cube app server will get you that slide deck. All right, that there. And let's see what I have other here. Again, all the other stuff. And let's see, anything else here? Dun, 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 dun. How does Kubernetes work with Docker? Okay, that's actually a good question. And I kind of probably went through it real fast. I'll just flip back up here. How does Kubernetes work with Docker? If you look at this diagram right here, so if you're familiar with Docker, most people are, right? Docker build, Docker run. Docker build, Docker run. That's the pattern you've put into your muscle memory at this point. Well, in this case, you do a Docker build, and make sure you push that image to a common registry, common repository, and then Kubernetes does your Docker runs for you, okay? So if you look at all these different nodes here, the kubelet on each of these nodes basically says, I'll do the Docker run, you just tell me what you'd like me to run. Docker run, Docker run, Docker run, Docker run, Docker run, Docker run. So Kubernetes is doing those Docker runs. And the cool thing about that is that's only if you're using Docker as the internal container solution. That's being replaced with cryo and other technologies, right, from OCI. So basically an open standard for these kinds of images. You're going to see different solutions there. Like cryo is a good example. It runs a lot faster. You also see technologies like Builda for building images in a different way, Builda and Podman, as well as a technology from Google called Kaneko. So there's a lot happening in that space. So Docker build will eventually go away, and Docker run has mostly gone away at this point. Kubernetes manages all that for you. All right, hopefully that answers that question. Let's see here, was there another one? Good resources for getting started with Kubernetes. And that's actually a tricky question. So this is a class that I teach for O'Reilly. Let's see, awesome. So this one is called 9 Steps to Awesome with Kubernetes. It is an intro to Kubernetes where we kind of walk you through all the basics of Kubernetes and how to get started with a Minikube locally, like I have running here on my laptop just now. And then that's the way to get started. There's also a series of books that are out there. Let's see here. Like there's this one called, I don't have it linked here. It is the Kubernetes Cookbook that I like. Yeah, these guys right here. So Sebastian, who's also a teacher out there at O'Reilly, as well as Michael, who used to work with me at Red Hat. They wrote that book there. It's another great book to get started with Kubernetes. But if you just go to the Kubernetes website, it is absolutely brilliant when it comes to all the content you might be interested in there. If you're interested in Istio, you can check out the book that I mentioned earlier, but there's also this bit.ly Istio tutorial, which takes you into our document that we maintain, and will show you how to run Istio on top of your Kubernetes and deploy your microservices, set up your observability, deal with your traffic control, service resiliency, circuit breaking, things like that. And if you're interested in Knative, which I'll mention Knative in the next section, that's the Knative tutorial. Okay? So there is a ton of content available to you out there in the ecosystem to start learning, start growing. Minikube on your laptop is what I'm running here. And it's running, in this case, as a virtual box entity. And actually I have 2 running right now, right? I have an OpenShift one and a Kubernetes one. Okay, and I think we now are just about out of time. Let's see if we have another question here. Maybe I'm supposed to do something with these when I answer them. No? And I think we got them all. What's that?
The difference between Kubernetes and OpenShift.
Oh, difference between Kubernetes and OpenShift. Yeah, good point. I just saw that one. Where is that? Okay, here we go. This is actually something I show my intro class. So again, OpenShift, there's Red Hat's distribution of Kubernetes, kind of like there's Red Enterprise Linux and there's Linux kernel, right? So it's our distribution of Kubernetes. So it certainly is Kubernetes, right, with all the things you get there. But there's some additional components that we've added to it for enterprise use cases. So we provide it for often on-premise use cases. So you can see there's multi-tenancy. There's an SDN out of the box. There's an image registry out of the box. There's the build tools, metric capture, log aggregation, ingress solution, basically called routes based on HA proxy. There's a special console, special service catalog. So there's a lot of stuff that's in there, and it's secure by default. So by default, a Kubernetes cluster kind of lets you just log in and use it like a developer would. In our case, ours is locked down automatically. You got to log in appropriately and use the resource. So you can kind of see that OpenShift just has a bunch of things pre-bundled in. You can also bundle these in yourself, right? Because these are all open source projects, right? So it's still your EFK, Elasticsearch, FluentD, Kibana. It's still your logging. That's for your logging infrastructure. It's still your Prometheus and Grafana. That's your metric infrastructure. It's still HA proxy for your ingress solution. All those things are still part of the architecture. Persistent storage is based on Rook now and Ceph. So all these things are still out there. Most of it's actually out there at the CNCF. If you look at it from that perspective, if we go to CNCF, you will see that there. And so, if you look at all these projects, so there's FluentD, there's Envoy, that's with Istio, Kubernetes, Prometheus. You kind of see there's Rocket, CNI, that's the networking one, Helm, Linkerd, right? So there's just tons of stuff that's out there as open source projects. Okay, let's see, is there one more question? That might have been it. Okay. Well, I think that's it. So let me take some time to go back and figure out why I can't get my clusters to run on this network so I can get it ready for the next presentation. I'm going to make the damn thing run somehow or another. and then we'll show you those additional demos this afternoon. I want to thank you for your time. And if you can always find them.